Abinitio architecture. Okay, so before getting started with the Abinitio architecture, so let's refresh some basic things. So then we can get into the Abinitio architecture. So for that, right? So first, let's discuss about the two different ways of processing. So one is serial processing, another one is
Mm-hmm.
parallel processing.
Mm-hmm.
So if it is serial processing, can you give an example for serial processing and parallel processing?
Mm-hmm. Serial parallel processing where or serial processing where we are not using uh, any but the any partition components. The
That's right.
flow is serial where we have
Okay,
it. Yeah,
that's right.
everything will go in the serial way.
That's right. That's right. So let's take one real-time example. Okay. So say for example, you have three different processes. Okay. So process P1, process P2, process P3. Okay. So we have three different processes. So if it is a serial processing, so the processing will happen one after another. After the completion of the first process, only then the next process execution will start. Right. So here, so after the completion of P1, so then the process P2 will begin. Once the P2 gets completed, so the process P3 will start. So this is how the serial processing will happen. So this increases the processing time. So because the processing is happening in a serial way. So in order to improve that, so we have the parallel processing where we can have all these three processes can run simultaneously, right? So we can have P1, P2, and P3. So if it is parallel or concurrent processing, so we can process all the three process at the same time. At the same time, we are going to process all the three process, which means all the three process are going to run at the same time. Okay, so your total processing time will get reduced to one third of the time which took for the serial processing, right? So for improving the performance, we can
Mm.
go for the parallel processing, right? So for there are two different types of real-time architecture that we have. Okay, so we'll see about the two different real-time architecture. So this real-time architecture is suited for any technology. Okay, so this is not only for ab initio, for any technology. So this architecture is suited for other technologies as well. So we will see what is the real-time architecture and what are the two different types of real-time architecture and how it is suited for ab initio. Okay, so we'll start with
Okay.
real-time architecture. So for the real-time architecture, we have two different types. One is symmetric multiprocessing. Okay, one is symmetric multiprocessing. Another one is massively multiprocessing. Okay, so what is the difference between these two architectures? Have you heard of these two architecture? What is the difference between these two architecture?
No, not
Okay,
before.
okay, okay, yeah. So the symmetric multiprocessing, so it is nothing but you are going to have one computer, okay, one computer with multiple CPU cores. So where you can have multiple processes which can run concurrently. So which is nothing but symmetric multiprocessing. Symmetric multiprocessing is nothing but so one node, okay, one node with multiple CPU cores. Okay, so that is symmetric multiprocessing. So if it is massively multiprocessing, so we can have multiple nodes connected together to form a cluster, and each node can have multiple CPU cores. Instead of doing the processing in one machine, so you're going to process in multiple machines. That is massively multiprocessing. So massively multiprocessing is nothing but multiple nodes having multiple CPU cores. So I would say each node can have multiple CPU cores and connected together in a network called a cluster. So you're going to connect a set of nodes and you're going to form a cluster and you're going to do the processing in a cluster. Okay, so that is massively multi or massively parallel processing. Okay,
Okay.
so let me show you a pictorial diagram for the symmetric multiprocessing as well as for the massively parallel processing. So you can, I think it would be better if you go through this diagram. So let me show you the diagram for symmetric as well as massively multiprocessing. So you can take this example. So if it is symmetric multiprocessing, you can see. So you have the CPU in the RAM in a computer. So where for a CPU, the CPU can have multiple cores. So the process can run in different CPU cores concurrently. Okay, so you're going to have only one node if it is symmetric. If it is massively parallel processing, you're going to have multiple nodes. You can have more than one node, so each node can have multiple CPU cores. Okay, so that the process can run simultaneously, right? So you can take so instead of processing in one single computer, you're going to do the processing in multiple computers. Okay, so that based on the number of nodes and the resource capacity, so your performance will get improved. So is this clear? Do you have any questions on symmetric or massively parallel processing?
So when we will go for this, or that would be only dependent on the client actually, client base actually.
That's correct.
I got.
Client data volume. Yeah, there are different parameters that we have to consider. So the data volume, the processing capacity, and your performance. So based on this, so your turnaround time. So based on the different parameters, we have to choose either symmetric or massively parallel processing.
Okay.
So this architecture suits for any technologies. Okay, you can take any
Yes.
technologies. So it suits for any technologies. You can take the Hadoop-based processing, or you can take an example of Teradata. So Teradata supports massively parallel processing. So Abinitio supports both symmetric and massively parallel processing. So all the technologies you can relate it with this real-time architecture, right?
Yes.
So, and
Yes.
there is,
Yes.
yep, and there are two things. So here, if you see here, so I have specified the two different resources, right? So one is the CPU, another one is the memory. So what is the role of the CPU and the memory? So what is the main purpose of the CPU and the memory? So when I say memory, so there are two different types of memory, right? So one is main memory and another one is secondary memory. So what is the role of the CPU and the memory whenever we do the processing? So if we are processing anything, so say if we are running an application, so process is nothing but execution is a program, is an executing program. So if we are running a program, then it becomes a process, right? So whenever you are running a program, so it makes use of CPU and the memory. It is going to use CPU and memory. So what is the use of the CPU and memory for executing the program? So for executing the program, what is the role of the CPU and the memory?
I think CPU is for the allocating the resources
That's correct.
that
That's correct. That's
that
right.
we
So it
have
is
it.
for process management. That's right. What is the use of memory?
Between I think this main memory you were saying is like the RAM, which you have it
That's
in
correct.
memory,
That's right. That's right. In
and
memory
then
processing. That's right. That's
swapping
correct.
will
Swap in and
happen
swap on will happen in the hard disk. That's right.
hard disk. Then it will
That's
go
right.
to secondary.
Exactly. That's right. That's right. So process, all the processes are managed by the CPU. So where it gets the required inputs from the input output devices for displaying the results to the user, everything will be taken care by your CPU. And for the memory, so whenever we do the processing, so we need to store the data, right? So for storing the data, so the data will get stored in the main memory. The data will get stored in the main memory. If there is no space in the main memory, then it will be stored in the hard disk in the form of temporary files, right? So once the main memory gets freed up, the data from the hard disk will move to the main memory, and it will do the processing. Right. So this main memory plays a very vital role in the process for executing a process. So for executing a process, this main memory plays a very vital role. That's right. So with this, right? So we'll start with the ab initio architecture. Before directly getting into the ab initio architecture, so I would say Abinitio supports both the real-time architecture, right? So Abinitio supports symmetric as well as massively parallel processing architecture, right? So Abinitio supports symmetric and massively parallel processing architecture. Now, before that, I'll just give an introduction to the client server architecture. So then we can see the ab initio architecture. So if we take this example, okay, if we take this example, so for this example, so we can have multiple client application, right? We can have multiple client application, and we have one server where the application is hosted on the server. So client can connect to the server, right? So it makes a request to the server. So the server will do the processing. So the processing will happen in the server. So once the processing gets completed, so it will send the response back to the client. So can you give any example for this client server architecture? Any real time example for this client server architecture?
In database DBMS we have that.
Right, DBMS, you have database client. So using the database client, you can connect to the database server for data storage and
Yes.
data retrieval. That's right.
Yes.
Right. The client
Yeah.
requests for a service to the server, server the processing and send the response back to the client. Right. So with this, right, so we'll discuss on the ab initio architecture. So for that, right, so there are two different types of ab initio architecture. So one is the legacy architecture, the other one is the latest architecture. So first, let's see on the legacy architecture based on the GD and the cooperating system version. So let's, so if you take the GD, So the GD version initially, so the base version of GD is 1.10 and the cooperating system is 2.10. So post to that, they started to release multiple major versions, 1.11, 1.12, so till 1.15. And here also, so you will have 2.11, 2.12 till 2.15. So later, so once it reaches 2.15, so then they will start to release the other version, so which is 3.1, sorry, 3.0, starting from 3.0, 3.0, 3.1. Here also the same, so you'll have the same 3.0, then you'll have 3.1, then you will have 3.2 till 3.5. So here also you'll have 3.2 till 3.5. So later, so they started with the 4 version 4.0, then 4.1. So currently it is 4.1.7. So when we say 4.1.7, so this 7 is going to be the minor version. So in case of any patches, they will release the minor version. And for the cooperating system also, it is 4.0 and 4.1.7. 7 is the latest cooperating system version. Okay. So
Okay.
with so for this, right? So there are two different types of architecture. One is the legacy architecture, another one is the latest architecture. So it is based on the cooperating system version. Okay, it is based on the cooperating system version. So say if your cooperating system version is less than or equal to 2.14. Okay, so till 2.14. Okay, so till 2.14, we have an architecture. We have a architecture. So when I say the Abinitio products, so we have other than the GD and the cooperating system. So GD is for the development of the graphs with the help of the components. So cooperating system is mainly used for running the job by creating different processes, managing the processes and memory, checkpointing, resourcing. So everything will be taken care by the cooperating system. So when we have the enterprise metadata environment, so which is for the version management, right? So which is for version management, and you have conduct IT, so which is for grouping a set of jobs, grouping a set of jobs by setting the dependencies,
Yes.
and we have control center for scheduling and monitoring, and we have continuous flows for real-time data processing. We have express IT. So this express IT is a combination of two products. Okay, so one is BRE and application configuration environment. So initially they had it as two different products. Okay, so till if you see till 3.1, so they had two different products. One is BRE and another one is ACE. So later, so instead of having it as two different products, they merged these two products and they released a new product called Express IT. Okay, so using Express IT, we can create app templates, app configs, and you can create rule sets. So app template and app config are the features of ACE, and rule sets are the features of the business rule engine. So we can do all these things with the help of the Express IT. So then we have metadata hub. So this metadata hub is used for data lineage. Okay, one purpose most of the projects will use this for the data lineage to see how the data from the source gets transformed and loaded into the target system to do the impact analysis. So impact analysis in the sense, so when there is a change in the source or the target attribute, if there is an addition of a column or there is a change to any of the column data type, so data type or data size, so what are all the impacted jobs? So if I have to find the list of impacted jobs, we can find it with the help of the data lineage feature, which is available in the metadata hub. So we can use it for data lineage. Other than that, so we can have the imports and exports. So the imports and exports is more of so we can store all our reference data. So whatever the reference data that we get from the reference system, so we can store it in the metadata database. So those lookups can be those reference data can be used as a lookups while doing the application specific process. So whenever your application specific job runs, those jobs can make use of those lookups. So when we say lookups, the lookups are being loaded from the Excel to the metadata hub database. So from the metadata hub database, so we are going to export the data and then create the lookups. So those lookups are going to get used in our jobs, application specific jobs. Along with that, we can do exports also. So when we say exports, so from the metadata database, so from the metadata database is an Oracle database. So it has a set of tables. If we have to join those tables and create reports out of it, we can create reports or we can extract the data by joining the metadata hub tables, and you can generate the report using the exports functionality. Okay.
So it's a by default Oracle only, right?
Yeah,
For
it's an Oracle
Abinitio.
database. I think. Yeah, it's an Oracle. It's an Abinitio provided database. We don't have a
Okay.
control on the database. So the schema is maintained by Abinitio. For the control center, also the same. So for the control center, so for storing
Yeah.
the audit
Okay.
information, so it is an Oracle database, and the schema of the database is maintained by Abinitio. We cannot do the schema level
Okay.
changes. So when I say schema level changes, we cannot add
Hmm.
table or we cannot alter the column size or length. So those things will be taken care by the Ab initio corporation, and they will release it as a different version or a patch. They will give it as a patch.
Okay. Do we have an access to those tables?
Yes, we can access. Yes, we can access those
Okay.
tables. Yep, we can do that.
Okay. Okay.
Right. So other than this, we have other products also available. Okay, right? We have so in Express IT we have a feature called so you can do the data profiling as well. So we can do data profiling and data quality checks. Okay, so we can do data profiling and data quality checks. So we used to have a separate product for data profiling. So later they have added this functionality in Express IT, and also in GDE there is a component to do the data profiler. So there is a data profiler component. Using that data profiler component, we can do the data profiling as well. So the data profiling is more of so how many null values that we have from the source. So we'll do a column level analysis, right? So when you are onboarding any new source, so for that source, how many number of null values, blank values, so and what are all the distinct values that we have? How many number of duplicates that we have? Based on that, we can decide the primary key, right? So based on that, we can decide which column can be a primary key, right? So doing the data analysis before onboarding an source system, so we can do this data profiling. So this data profiling can be done through Express ID, or we can do it from with the help of the component which is available in the Abinitio GDA. Right. So now coming back to the architecture. So as I said, right. So based on the based on your cooperating system version. So coop is the heart of the ab initio, right? So cooperating system is the heart of the ab initio. So where the actual processing is happening, right? So it is taking care of the processing of the jobs, right? So the actual execution happens in the co-op installed machine, right? So co-op is an application, so which can be installed. Co-op is an application, right? So co-op is an application which can be installed on Unix or Linux, Windows network-based operating system, Windows NT or Windows server-based operating system. Uh, so when we can have this installed in mainframe as well. And you can have the cooperating system installed on mainframe as well. Co-op is a server-based application, right? So when we say server-based application, so the cooperating system can be installed on the server-based operating system. So these are all the server-based operating system. When we say server-based operating system, so it is multi-user, multitasking, multi-user, multitasking operating systems. So when I say multi-user, so multitasking, right? So we can have multiple processes can run simultaneously. So what do you mean by multi-user? So what is a multi-user operating system?
It's a guess like multiple or the same user can log into same machine multiple times.
Okay, so that is again sessions, right? So it is user can have multiple sessions, right? So if I
Sessions,
take
yeah.
if I take user one, so the user one can have multiple sessions. So session one, session two. So like this, he can have multiple sessions. Like this, we can have multiple users. So we can have user two, we can have user three, user four. So like this, we can have multiple users can also make use of the server at the same time. Right, so we can have multiple users. It is multiple users can log into the machine and make use of the system at the same time. That is very important. So multiple user can log in and utilize the system at the same time. So that is multi-user operating system. So when I say utilize, so they can utilize the system resources, CPU and the memory. Okay, so they can make use of the CPU and the memory, so which is being shared by the other users as well. Clear?
Yes, yes, yes.
Right. So now coming back to the GD, right? So GD, we know it's Windows, it's front end, right? So it's an GUI based application, so which can be installed on the Windows machine, right? So Windows, any flavors of Windows supports the GD. Okay. So now, so with this, right? So I said two different architecture. One is legacy, another one is the latest architecture. So in the legacy architecture, so first let's see on the legacy architecture. So the legacy architecture is your ab initio cooperating system version less than or equal to 2.14.
Okay.
Right, so it is till 2.14. We call it as legacy architecture. Yeah, what is this legacy architecture? So why we are calling it as legacy?
Actually, no idea, to be
Okay,
honest.
so yeah, so that's fine. So for the legacy, right? So so from the GD, So we have to establish two different connections. Okay, so probably yeah. So this cooperating system is very old. Okay, so at 2008 or 2007, during that time, this particular cooperating system was there. So during that time, what we have to do is so we have to establish two different connection. Okay, so one is for connecting to the cooperating system, and another connection to connect to the EME application. So if you see in the latest GD, so starting from 3.0, so you will have only one option, right? So we will go to the settings and then manage connections, and you can connect to the AppHub. AppHub will connect to the cooperating system for running the job, EME for the version management, right? So but in the
Yes.
older version, in the older versions, so there will be two different options, one for cooperating system, one for the GD. So for cooperating system, it is run settings. So you have to go to run. There is a menu called run in the GD. So you have to go to run, then you have to click on settings. So for connecting to the cooperating system, and you have the repository. You have a menu called repository. So the repository is for connecting to the EME application. So you'll have run settings. You'll have two options: run settings, and you'll have a repository. Okay, for connecting to the this run settings is for connecting to the cooperating system. This is for connecting to EME application. Let me show you this architecture. Okay,
Yeah.
so you can see this. So if you see here, so we have the server. Okay, so we have a server. So this is a server based operating system. So the server based operating system can be an Unix or Linux, right? So in most of the real time projects, it will be Unix or Linux. So then, so you will have the applications, right? So you have the cooperating system and EME installed. So from the GD, so the user has to establish two different connections. So one for connecting to the cooperating system, one connection to connect to the cooperating system, one another connection to connect to the EME application. Okay. So is it really required to establish two different connection? Is it really required to establish two different connection?
Okay. Yes, that we overcome with the Abinitio version or the version.
Yeah, that's right. So that is more with respect to the configuration settings that we have to make for running the co-op or EME specific commands
Uh,
from the server, right? So from the run host
uh,
or
um,
from the server where the co-op and the EME install. So we have to do those settings. That's right. So there is more for running the commands, for running the co-op or EME commands. So we can do the configuration settings. That's right. But do we really require these two connections? So
no.
here we are. Yeah. So because the applications are installed on the same server, right? So
Yes.
you are having both the applications installed in one server. So but you are establishing two different connections. So this will increases the network traffic, right? Say if we have multiple developers. So if you have 10 developers, so each developer is going to make two connections. So the number of connections becomes 20, so which increases the network traffic and impacts the performance. Right. There is no need to establish two different connections. Right. So because we have these two products installed on the same machine. If it is different server, yes. If it is different server, we can have multiple connections. But if it is same server, there is no need to have multiple connections to connect to the applications which are installed on the server, right? So another connection to EME for version management. So
correct.
due to this, okay, so this is the drawback that we have. So this is the drawback or disadvantage that we have in this architecture. So this disadvantage that we have in this architecture, multiple connections, which impacts the network performance. So for that, so starting from 2.15 cooperating system, okay, so which is your latest architecture. So starting from 2.15 cooperating system, so they introduced a product called Application Hub. So which is a kind of uh, router or a switch. So which is used for
Middleware,
which is
we can
used.
say.
Yeah, that's right. So it's an application hub. So app hub. So which is used to switch between POP and EME application. So from the GD, we have to establish connection only to the app hub. So app hub will be responsible for connecting to the cooperating system as well as the EMA application. Okay, so I'll show you the architecture. So you can see this. So for, I'm just not scrolling it further. So there is a reason behind it. So we will discuss on that before scrolling down. Okay. So you can see here. So you are establishing only one connection to the application hub. So application hub is trying to connect to the cooperating system as well as the EMA application. So it connects to the cooperating system for running the job, and EMA application for the version management. Okay. So now, so we are using the terminology called run host, right? So this is very important. So there are two things. Okay, one is a run host, and another one is processing host. Okay, one is run host, and another one is processing host. What is the difference between run host and processing host?
Mm, Run host, I know, where we are installing the app hub and the cooperating system,
That's correct. So it's a primary
where
server.
the processes, yeah,
That's
it
correct.
runs the responsible, and I think processing host will be the server only which is responsible for running the processes.
But the process is
Mm,
running from the run host also, right? So
Run
from the run
host only,
host,
run host only, yeah,
yeah,
yeah, run.
right. So we will see that. So run host, it's a primary server. So where we can install app pop EME for jobs execution. So it is a server from, I think I would say, so establish we always establish a connection to run host from GD, right? So we always connect to the run host only, right? So we always connect to the application hub which is installed on the run host only, right? So because it is the server which is responsible for running the jobs. So the processing computer is for it is a secondary server. It is a secondary server, so which is used to That is also used for running the jobs. Okay, used to run the jobs. So a secondary server for running the jobs to improve the performance. Okay, for performance improvement, so we can have n number of processing computers. So it is nothing but, so we discussed about two different architecture. One is symmetric, another one is massively parallel processing, right? So if I have only run host, if I have only one computer, so then it is a symmetric multiprocessing based architecture, right? So if you take this architecture, okay, so if you have only one run host, that is a symmetric multi-processing. So you can have multiple cores. So the process can run simultaneously. It can run concurrently in one node in one computer. If I have a processing computer, okay, if I have another server called processing computer, this is more of an Ab initio specific terminology. The run host and the processing host are an Ab initio specific terminology. So where and which, so we are differentiating it as a primary server and the secondary server. So run host will always be one single machine. Processing host, we can have any number of machines. We can have any number of servers, right? So we can have any number of servers so that we can run the jobs from the run host as well as from the processing computers. Instead of running the job from one single computer, you're going to run from two or more computers. Okay, so that is massively parallel processing based architecture. So in Ab initio, if you want to go for symmetric multiprocessing based architecture, so you will have only run host. If it is massively parallel processing, so then you will have the run host as well as the processing computer. Okay, so on the processing computer, so I'll show you this massively parallel processing architecture. So you can see here. So you're going to have the processing host. You're going to have along with a run host. So you're going to have the processing host as well. Okay, along with this run host, you're going to have the processing host as well. You're going to have the processing host as well. So on the processing computer, you will have only the cooperating system. Okay, there is no need for the EME to be installed on the processing computer. You can have only the cooperating system installed on the processing computer. So because it is for running the jobs, right? So for running the jobs, we need the cooperating system, right? So we can have the EME still on the run host. So when we say processing host for running the jobs, so we can have we can have serial way processing. So when I say serial way processing, so we can have say you are developing one job. Okay, you are developing one ab initio graph. So in the ab initio graph, you have 20 components. So what you can do is you can make 10 components to run from run host and the remaining 10 components to run from processing computer. We can do that. Okay, we can make 10 components to run from run host and 10 components to run from processing host. So if it is a serial way, so it's a serial way processing. So in one single job, so we can have 10 components to run from run host and 10 components to run from processing computer. And if it is a multi-way processing, if it is a multi-file processing, so where you're going to have multiple partitions, right? So you're going to have multiple partitions. So when you are having multiple partitions, so what we can do is we can have, say for example, you have 8 partitions. So we can have 4 partitions to get processed from run host, the remaining 4 partitions to get processed from the processing host. We can do that as well. Okay, there are two things. One is serial file processing. If it is serial file processing, so we can decide where the components have to run. So whether it has to run from run host or the processing host, we can do that. Can you tell me how we can do that? So we can set how where the component have. to get executed. So whether it has to be executed from run host or it has to be executed from the processing host. So how do we do that?
No idea. Actually, I'm going to ask you the question on that
Okay,
actually. The
okay,
notes we have that option, but
okay,
I'm not aware exactly
okay. I
because
think so. You are
how it.
yeah you are aware. I think so. You have to relate that with the
Okay,
with the massively parallel processing. Okay. Have you
okay,
heard of layout? Have you heard of layout?
yeah, yeah, okay, okay, yeah, yeah,
Yeah, we can do that with the layout. So in the layout, you can specify the server along with the path, along with the file path. You have to specify the server name
hmm,
so that the component
okay,
will run on that server. So we can do it with the help of the layout. So this layout is the one which decides where the components process have to be executed, right? So decides
okay,
where the
but
component process.
okay. So apart
Yeah,
from
go ahead,
that,
please.
there is no. Apart from that, there is no other way where we can decide, right? Wherever
Yes,
means
that's right.
yeah,
So
because it layout is the one where it creates the temporary files and with which the component will execute over there.
exactly.
But
So when we say
from there,
temporary file, yeah, when we say temporary file is getting created, so which means the job is getting executed from that server,
execute.
right?
Yes, yes, yes. But
So
dynamically, it will not select the server, right?
no,
We'll have to.
dynamically it will not. No, we don't have a provision like
Yeah,
the
that's
HDFS architecture. Yeah,
yeah,
that's right.
yeah, 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 right, right, right. That's what actually I wanted to
Okay,
ask
okay,
ask you. Yeah,
okay.
yeah. Okay, okay.
Right. So whenever you specify the layout, right? So you normally use whether it is a serial file or a multi-file using this label, right? File colon or M file colon, right? So here if you use this file colon and you can give the file path, right? So say you are
Yes, yes.
specifying the file path as ab initio data, then serial stash. So you have the say for example, so you have retail, then retail underscore data mart, so then you have main. So within this, so if you specify this main, so under this main it creates dot work directory. So under this dot work directory you will have all the component process specific files, right? So like when you specify this, so this is for the run by default. So if you specify this, so this denotes run host. So when
Oh,
you are specifying along with this, if you are specifying the server name, so if you give the server name, say dev server 2.abc.com. So if you give the server name, okay, if you give the server name along with the file path, so then it is more of so all your temporary files will start to get created in your processing computer.
yes.
So how it will connect to the processing computer? So along with this, do we have to do any other settings? So this from the
Passwordless.
uh, yeah passwordless connectivity that we have to
Okay.
establish, or we can have a password based connectivity also. Where do we need to specify this? So we have to specify somewhere, right, for connecting to the processing computer. So where do we specify that?
Mm, I I think we are not I never
Uh,
I have never seen specified it. I just did the passwordless connectivity with the certification might be RSA or DSA. We have it and we
uh,
did it.
okay.
Or in the Abinitio RC might be will
Ah, yes. Ab initio RC. That's right. Ab initio RC. See, ab initio has to know, right? So
yeah.
we can do an SSH to the secondary server, but the ab initio should know, ab initio co-op should know that we have
Mm,
the secondary server for processing this job. So for
Okay.
that, right, we have to specify it in the Abinitio RC file. That's right. So we have to specify in the
Okay.
Abinitio RC file with the server details. We have to specify the server name. We have to specify the user using which we want to connect to that server. If it is passwordless, there is no need to provide the password. If it is password based, we can encrypt the password and provide the encrypted password. So how do we encrypt the password?
M
So we can
underscore
encrypt,
encrypt.
yeah,
Yeah.
m underscore password, m
Uh,
underscore password we
M
can use.
underscore password. Sorry. Yeah.
Yeah, m underscore password hyphen prompt, or you have multiple options. So we can use hyphen prompt. So this will ask for the password twice, and then it will give you an encrypted password.
Yes.
Correct. So encrypt the password. Right. Okay. So this is for a serial file processing. So if it is a multi-file processing, if it is a multi-file processing, so it is more of you can have more number of we can create partitions. We can create partitions. Um Partitions based upon the data volume. We can, based on the data volume and the available resources, we can decide the number of partitions. So we can process the data in each partition simultaneously, right? So that is multi-file processing. So we have this data parallelism also there, right? So we have this data parallelism and abinitio. So where we can partition the input data, right? So where you can partition the data, partition the data. So here I would say we can partition it as 4-way or 8-way or 16-way or 32 ways, 32 ways, and process the data in each partition. Process the data in each partition simultaneously. Right, so we can process the data in each partition simultaneously, which is your multiple processing. So for this multiple processing, so we can have all the, say you have the depth of the parallelism. So let's say the depth of the parallelism is going to be going to be 8. So for this a depth of for this 8 a depth of the parallelism. So if it is 8, a depth of the parallelism is 8. So we can have 4 partitions on run host, and we can have the 4 partitions, 4 partitions created on the processing host. We can do that. Okay. So how we can do that? So for how we can do that? So we have a command, right? So m underscore mkfs. So the m underscore mkfs is to create a multi-file system. Before you go for multi-file processing, so first you have to create a multi-file system. So for creating this multi-file system, so we can use this m underscore mkfs. So for this m underscore mkfs, so we have to provide the control partition as well as the data partitions. Right. So here
Oh,
you will have the control and the data partitions. So when I say control, so it is a list file. Okay, control file is a list file that will have the location where exactly the data partitions resides. So data partitions are nothing but so data directories where you are going to store the actual data. So if you use this m
yes.
underscore mks, you have to specify the control directory, and also we have to specify the data directory. We have to give a data directory 0. So like this, you can specify based on the depth of the parallelism. We can specify the number of data directories. So if you are specifying this data while creating this multi-file system, so if you want to place two data directories on the processing computer, what we have to do is we have to give this corresponding server name. So let's say, so data directory 0 and data directory 1 has to be created in run host. So there is no need to specify the server name. So for data directory 2, along with the data directory path, so you have to specify the server name. So here you have to specify the server name. So dev server dot abc.com slash, you have to specify the data directory location. So that it creates the data directories on the processing computer. Okay, so that it creates the data directories on the processing computer. So whenever you are doing the processing, whenever you are running an Abinitio job, so it will, so the two partition data will get processed from the run host. The remaining two partition data will get processed from the processing computer. So is this clear? Do you have any questions?
No, it's clear.
Okay, fine then.
Yeah.
Right. So now we will see on what will happen whenever you run the job. Okay, so whenever you are running an ab initio graph, right? So uh, what exactly will happen in the background? So what are all the different process that will get created in the background, and what is the use of those process? Okay, what is the significance of those process? And we will take some real-time example or real-time example to see to understand how many processes gets created. So whenever you run an ab initio job, okay. So when you are running an ab initio job from the GD, right? So when you hit the run button, okay, from the GD, if you are hitting a run button, so the
Mm-hmm.
your graph will get converted into a script, right? Your graph will get converted into a deployed script,
Yes.
KSH script, right? So that deployed script will get deployed to the run host. So on the run host, it creates a process called launcher process. Okay, the first process which gets created is launcher process. So once the launcher gets created, so the launcher will create the agent process. Okay, so agent process is nothing but, so based on the number of processing computer. Okay, so in the run host, it will create one agent. So and you, if you have a processing computer, on the processing computer it creates one agent process. You will always have one launcher. Okay, so launcher is a kind of a manager, so which manages the results from all the processes, all the other processes. So this launcher will create the agent on the run host as well as the processing computers. So if you have multiple processing computers, it creates the agent process. Once the agent gets created, the agent will create the component process. So when I say component process, so for each ab initio component, if you are using an input file, reformat, rollup, scan, output file, for each of these components, it creates a component process. Okay, it creates a component process. So so this component process is the one which actually does the execution. Once the execution gets completed by this component process, it sends a message to the agent. So the agent will wait for the messages from all the component process. Once it gets the messages from the component process, stating that the jobs are completed, so the agent will send a message to the launcher. So launcher will wait for getting the same message from all the agents. So because you have the job running from the processing computer as well, right? So from the processing computer also, say from the run host, if it gets completed, the agent will give completed message to the launcher. Launcher will wait for the processing host agent to send a response. Once the processing host agent send the response to the run host launcher, it consolidates all the results. So if the process gets completed, then the launcher will send the completed message to the GD. If there are any issues, if there are any failures, then it will report those failure messages to the user from the GD, through the GD. through the GDE, the user can see the error message. Okay, so this is how it works. I'll show you the diagrammatic representation, and probably we can walk through again so that it will be much more clear. So you can see this. So from the GDE, so if you are hitting the run button, so it creates a deployed script. So this deployed script the deployed script will be deployed to the cooperating system. The cooperating system will create a process called a launcher. So the launcher will create the agents. Will create the agents, one on the run host and another one on the processing computer. The agent will create the component process. Okay, the agent will create the component process. So the component process so will does the execution. So once the execution gets completed, it will send the response back to the agent. So the agent will wait for all the components to get completed. So say this component says completed and this component is running. So this agent will wait for both the components to get completed. Then this agent will say to the launcher that so all the components are completed. So then this launcher will wait for the agent which is created in the processing computer. So until this agent in the processing computer gets completed, it will wait. Launcher will wait. So the say for example, this agent will get the response from the components from the subsequent component process, and if once it gets all the messages, it will send the consolidated messages to the launcher. So launcher will then send the response back to the GDE. So the GDE, we can display the result. So whether it is completed or failed, we can see the status from the GDE. So is this clear? Any questions?
No, 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 no. Clear.
Right.
Just give me a minute. Just give me a minute.
Yeah, yeah, yeah.
Just give me. Can you? Really sorry. Can
No,
you
no, no.
please come again, or can you please repeat this process?
Yeah, 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 sure. Sure,
This
sure,
launcher.
sure, sure.
Yeah.
Yeah, yeah, not a problem. Not a problem.
Yep.
Okay.
Yep.
Okay. So from the GDE, okay, so from the GDE,
Mm-hmm.
whenever you are running a job, whenever you are running a graph, so your graph can have, so let's say you have an input file, so then you have a reformat. Okay, so let's say a reformat, and you have an output file. Okay, so you have the input file is, let's say, a multi-file. Okay,
Mm-hmm.
so it is a multi-file. So you have four partitions. Let's take you have four partitions, and you have the two partitions on the run host, two partitions on the processing computer. Okay, so let's say when you are running this graph from the GD, so this graph will get converted into a deployed script, right? So this graph will get converted
Correct.
into a deployed script, right? So it will get deployed into
Yes.
deployed script. So this deployed script is based on the operating system, right? So it is
Mm.
.ksh if it is Unix or Linux flavor, right? So if it is Unix or Linux based operating system, it is going to be .ksh. If it is Windows, then it is a batch file. Okay, if it is Windows, then it
Oh.
is a batch file
Okay.
.bx file. Okay, so once this deployed script, once this deployed script gets deployed to the cooperating system. So it will get deployed to the cooperating system, right? So cooperating system is the one which is going to run the job, right? So what this cooperating system will do is this cooperating system will create a process called launcher process. Okay, so this
Okay.
launcher process is a manager. This is the first process it will create. So this launcher will create agent process. Okay, this launcher will
Mm-hmm.
create agents. So these agents are nothing but, so these agents will get created. So one on run host. Okay, by default, it create one agent process on the run host. If there is a processing computer, it creates the agent on the processing computer as well. So this agent will further create the component process. Okay, this agent will further create the component process on each server. So you can see on the run host also you have the component process gets created. On the processing computer also you have the component process gets created. So once this component process gets created, this component process are the ones which does the processing. Okay, so actual processing happens in this component process only. This component process will do its processing. Say if it is reformat, it will do the transformations. If it is a sort, it will perform the sort operation. If it is an input file, it just read the data from the file that we have specified. So based on the component functionality, the component process will does its execution. Once the execution gets completed, say the reformat gets completed in the run host, so it will send a response back to the agent stating that I'm
Mm-hmm.
done with my work. I'm done with my work to the agent. So this agent will wait for this component to get completed. So once this component gets completed, this will also send the message to the agent. So
Mm-hmm.
this agent will
Correct.
send the message back to the launcher. Okay, once this two process
Okay.
gets completed, this will send the message back to the
Mm.
launcher. Launcher will wait for an another agent. So we have an agent created in the processing computer as well. So it will wait for the completion of the agent in the processing computer. When the agent will get completed, the agent will get completed only if the component process gets completed in the processing computer. If both the component
Okay.
process gets completed, then this agent will get complete, will say I'm done. So and it will send this completed message to this launcher. Now the launcher will send the response to the GDE stating the message whether it is completed or not. Job gets completed, or if there are any errors. Okay, if there are any errors, it will display the error message to the GDE.
Okay.
Okay, right.
And
So for this example,
how
yep,
many
yeah,
how many component
that is what we are going
they
to see. Yeah, that is what. Yeah, that is what we are going
okay.
to discuss now. Yeah. So how many number of processes that get created on each server, right? So we'll take this example, simple example. You have an input file, you
Mm-hmm.
have a reformat and an output file, right? So your output file is going to be a multi-file. Input file is an multi-file and output file is also a multi-file.
Correct.
Okay. So for this input file, so for the launcher, if we take launcher, so this launcher will always be, what is the count
Single.
of the launcher process? Yeah, one. That's right. So
Single.
it is always one. Correct. And how about the agent?
Yep. Looks like one, two, depending on
Right.
the
So it is,
yeah.
yeah, depending on the processing computer. That's right. So here in this
Yes.
example, we have processing computer along with the run host. So your agent is going to be two processes. That's right. So now coming to this component process, this is now a little trickier. Yeah. So how many number of component process will get created in this case? So it
Yep.
is based on the
Four
number
we
of
can see. Yeah.
partitions. So let's take this. Let's first
Okay.
see the run host. For the run host, for you have two partitions, right? So for you have an input file component. So the input file component is to read the data from two different partitions. So for reading the data from two different partitions, you will have two different process. So then for doing the transformations, so you will have two different process, component process, and for writing it to two different output file, you will have two different process. The same set of process will get created in your processing computer as well.
For the run host, can we just repeat for run host?
Sure.
Okay, on the run host, you're saying two
let's say, I think we'll see from a serial file. Then, if we discuss on the multi-file, it will be easy. Okay, so first let's take the serial
No,
file.
let it be multi only because serial it will be much easier.
Yeah, three process, right? So it is a straightforward. For
Mm.
each component, is going to create one process, right? So here it
Create
is.
one process.
That's right. So here it is going to be three component process, right? So here it is going to be three component process.
Mm.
But if it is a multi-file, it is at a partition level. So I would say, so you have three components and you have two partitions, right? So you have two partitions. So for each
Mm.
partition, it creates a process. For each partition, it creates a process. So you'll have six process which gets created. So the same way for processing computer as well. You have three components and you have two partitions.
But why it comes to 3 into 2? Okay, because you
For
have added.
because it is a multi-file processing. It is a multi-file processing. So it is more of, so when we say multi-file processing, so based on the number of partitions, you will have that many number of instances, right? So if you take this example,
Correct.
so
So
here
so two.
this is partition one. This is partition zero.
Mm-hmm. Mm-hmm. No,
So this is
got it. Means for the component part, uh, what I will
yeah.
say,
Go
the
ahead.
process. I got
Hmm,
it
hmm,
right. But and the agent and the launcher, it will remain the same. So
correct.
over there, the four will remain the same on the run host, and the processing will have only three, right?
How only three under
Apart,
the processing host? Why it is three in processing host? So because in processing host you have two different partitions, right? So you have four partitions. Out of four partitions, two partitions are on run host, two partitions
right,
are on processing computer. Hmm.
right. So two processes for a component and one for the agent, right?
Correct, one for the agent. That's right. So here, yeah. So here you can say, so this you can take. So this agent, one is for a run host and one is for the processing computer. Okay, so one is for run host and one is for the processing computer. So I have just summarized here. Okay, so just see here. So launcher is always one, agent is going to be two, right? So one is run
Hmm.
host, one is processing computer. Now the trickier part is on the component process. So on the component
Correct.
process, on the run host, it will have six processing computer. It will have six different component process. So totally, you will have 12 component process. So is this clear, or if you need any clarification, we can discuss on this. So
This is not clear actually for me.
yeah, we can
How it
discuss.
will, okay, how
Right,
it
we can.
will create the
Right.
multiple.
Yeah, so it is more with respect to the partitions, right? So when we say we are
Right.
partitioning the data,
Okay.
we are partitioning
Mm-hmm.
the data. Say, let's say you have these two sets.
Okay.
The highlighted yellow highlighted ones are running from a run host, and the green highlighted ones are running from the processing computer. Okay, so for
Correct.
this, right? So when we say data parallelism, so it's more like, so you are going to create multiple threads, right? So if
Correct.
when you are doing a processing,
Mm,
so if you are going to do the processing in partition zero, during the same time, you are going to you are going to process the data
mm-hmm.
in all the other partitions also at the same time, right? So
Correct.
whenever you do the processing in partition 0, during the same time you are going to process the data in all the other partitions as well. So if you see this, so this is how it creates. So you have partition 0. For this partition 0, it creates one reformat process and one output file to write the partition 0 data to the target. The same way, for partition 1, it has one reformat component for processing the data in partition 1 and writing the data to the partition 1 data directory. The same is applicable for partition 2 and partition 3. Is this clear? So here you can say 1, 2, 3, 4, 5, 6.
Okay, 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 okay. So for overall components, you will be saying like, okay, if it's four ways, then two, 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 and then three. Okay, yeah, got you.
Right.
As many
So I
components we have it, as many components
as
we
many
have it in the.
partitions. That's correct.
Yes,
That's
yes.
correct.
Okay, 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 okay. Overall, for the overall graph, you were saying we will have that many
Component
component
process
processes. Okay,
that gets created. That's right.
okay,
That's right.
great. Oh, okay. Yeah, yeah, clear, clear. Sorry, sorry.
Not a problem.
I thought, yeah, yeah. Some other thought I have it in my mind, so I got confused. Yeah, yeah. Clear,
Okay.
clear.
Okay. 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 Fine. Okay. So let's take one another example. Okay. So let's take it as to do work. Okay. So I'll share this document with you. So just go through this. So we will discuss this answer in the next class. Okay. So the same
Sure.
graph. Okay. So you have this graph.
Hmm.
So here instead of an input file, so you are going to have an input table component. Okay, so this input table is so you are yeah, you have an input table component, so reformat component, output file component. Okay, so for this, so you have a run host and processing computer.
Hmm.
Okay, so you have to tell me, so how many number of launcher component, agent and component gets created. Okay, so agent and component gets created. So this is one to do. Along with this, there is one another case. Okay, so the other one is the same job. So where your input table is going to be a SQL server table. SQL server table. Okay, input table is going to be a SQL server table. So this input SQL server table is the SQL server. Okay, so you here you are going to have run host, processing host, and you have one another host called gateway server. This gateway server is a Windows server, so where you have the SQL Server database installed. Okay, so you have your SQL Server database. Okay, so from the Abinitio job, okay, from the Abinitio job, it has to connect to the gateway server for extracting the data. So once the data gets extracted, so then the extracted data should be available in the run host. So from the run host, it has to partition the data. So then it has to create a multi-file. So when we say partition the data, we need multi-file, right? So here I would say we will have input table reformat partition by key and sort, and then you have a reformat and then output file. So here also you have a PVKS. Okay, so just go through this and try to see how many number of processes which gets created for the case 1 and case 2. We will discuss this in the next class.
Okay, sure.